Hello everyone, welcome back to SAT Math Question of the Day with Professor Brothers Chaiken and his brother Joel. It's me. We're here to hopefully show you how to approach studying for the Math SAT and actually how to approach SAT math questions. In terms of studying for the Math SAT, we're talking more for the digital side, which is after the winter of 2024 and starting 2024 for the United States for high school people. Khan Academy essentially tells you what's on the test. To find out how to get to this practice for free, it's all free practice. Watch our video from June 29th. They also have the non-digital side as well. So you could do Khan Academy for the non-digital side if you're going to take the SAT before January 2024. Anyway, we are going through all these problems. We're going through the advanced problems with the idea that we spend almost too much time talking about how to do these things. So then you can go back and take hopefully what you've gotten out of this thing, and you can try the medium and the foundation questions yourself. So we are going through this. I believe we are here in this subunit. And I think, wow, it was last Friday that we did this. I hope I can remember what we did. Probability. Oh. Wow. No, we didn't do any of those, did we? Yeah. So we went to linear and exponential growth. It's interesting how they organize this. Here they have the data stuff, and then they take a break and they do linear and exponential growth, which probably belongs more on the algebra side. And then you move back to data stuff, probability and relative frequency. So I think this is where we are. Today we're going to start our first practice question. Let's go. Once we see the let's go, we're really ready to go. Let's go. Here we are. The first question. So please read it yourself and try it and come back, and we will hopefully show you how to approach it or give you multiple ways to approach it. Okay, here we go. Age at first inauguration. So this has to do with presidents served 4 years or less. Okay, table is partially filled out. Okay, political science was interested in determining how the age of various United States presidents at the time of their first election related to the number of years they served in office. Got it. A table is shown representing that information. If, oops, I have to bring in a, so annoying, annotation. Okay. If 45.8% of presidents between 50 and 59 served more than 4 years, how many presidents is this? So we want the sum of 24. Let's just label A. Wait. And B. Wait. What are they asking for? Hold on. How many? The table is showing representing information. If the presidents, if 45.8% of the presidents between 59 and served more than 4 years, how many presidents is this? This comes down to, Seth, maybe you could help me. This comes down to more of an English question. Are they asking for the total number of presidents between 50 and 59, or only the number of presidents between 50 and 59?
Could you? I'm confused there. Could you get rid of that black thing that's covering the table?
There you go. They say is this.
Yeah. Okay.
Oh, I see. I see. 24 is the total. They give you the total, and they're telling you, can I put an A there? Or can I put an X there because we don't know that? Can I put an X? I can put an X there, right? Because we don't know it. And I can say 24 minus X, can I?
Yeah.
Okay. So if 45.8%.
But what I don't understand is so that the idea is that they give you a partially filled table.
Yeah, they give you a partially filled table.
Figure out the unknown entries from the data that's given.
I guess so. Well, when they say how many presidents is this? I hate the
word. A table
this.
is shown representing that information.
Right.
If 48 45.8% of presidents between 48% of the presidents between 50 and 59.
So that's this entry.
Served more than 4 years.
That's, yeah.
How many presidents? Okay, I don't know. What does this mean?
That's right. It comes down to an English question. Well, it's either the total number of presidents total, which I doubt,
Well,
or isn't it just X? The table is shown representing if 48% of the presidents for more than 4 years. How many presidents is this? I think it's X. I think it's just the number of presidents that are 50 to 59 that serve more than 4 years.
so X is 45.8% of the total of the presidents who served, who were between 50 and 59 when they were inaugurated.
So that would be X, wouldn't it be?
Yeah, yeah,
Yeah, that would be X.
yeah.
So why did I call this a probability relative frequency table? This is just a percent. This is just a question on percents, which leads us to
What is peculiar about it is that the problem is not figuring out statistics from the table, but the problem is from a partially filled table of data plus extra data.
a lot of extra data.
Not a lot of extra data. One equation of extra data. They're asking you to fill in entries in the table that they didn't show.
Yeah. Yeah, one.
This, I think, is a really dumb question.
Well, particularly.
It's a stupid. If the political scientist is interested in determining how the ages are related to the number of years served in office, what the political scientists should do is form a table of all the data, and then do some statistics on it.
Right. Well, my boat.
No, it's not a problem where he gathered the data differently. He was told that 24 presidents were inaugurated when they were age 50 to 59, and somehow the additional data was given. Okay, so be it as it may be a really dumb kind of question, I think your interpretation fits what the words say.
It's reasonable. My bone with the question is that this has nothing to do with probability and relative frequency.
Yeah, absolutely.
This is just a question of percent, and with that, I like to use the is-of formulation of the percent.
It's a question where some data, some relationship between some relationship among unknown data is given in words, making use of a fraction expressed as a percent, and you have to combine the relationship given in the problem with the data in the table.
Yeah, so you're just explaining it too complicated.
All right, good. Let's calculate it out. Let's see.
Now
let's see.
It's possible that Seth and I both are not reading the word "this" correctly. They're not very clear as to exactly what they want the answer to be. Okay, so it's 10.999. So if it's 10.992, this thing here is 10.992. Let's see if this makes sense. We're talking about a quarter. We're talking about half of 24. Half of 24 is about 12, and this is 11. So the calculator actually gave an answer that made sense, believe it or not.
Yeah.
So always good to check. That's an approach. Make sure you check to make sure your answer makes sense.
Yeah.
Okay, so let's see. What do you think? Okay, let's see if it works.
See what they say.
God! So that was what they meant. Everybody hates the word "this." How many times in English class the teacher says, "Don't use the word this"? So let's see how they did it. Okay, I share Seth's frustration with this problem. I hate the word "this," although I use it too much in my own writing in English. Okay, 3 steps. What does this have to do with probability? Let's convert this to a decimal by multiplying by 100. Then we should multiply this by 24. This will give us the value of the particular category. Okay, of the particular category. My God, what a weak explanation also, right? Right?
Yeah.
Weak explanation.
Terrible.
Weak question, weak explanation.
Yeah.
So what do you think? We've spent 11 minutes. Should we try to go to the next one, or you think we just cash it in for today?
Oh, let's go to the next one.
This question was so unsatisfying. It had nothing to do with probability nor relative frequency. Okay, here we go.
Yeah. Well, I think we should note that these are not questions that came from the College Board or had appeared on SATs. These are made up by the Khan Academy people.
Right, with presumption that they worked with the College Board. But the problem with this problem, in terms of the approach of it, is you have to figure out what the word "this" means. You can't do the problem unless you can figure out what the word "this" means.
I think it's not that bad. I think it's not that bad.
Okay.
But the subject of the problem is, as you said, I agree. It's not the title, probability and relative frequency. Title is wrong.
Right. Just because they give you
what the true title is. What the true title is. Inferring missing data. Inferring missing. Let's put it this way. Come on, how do we do it? Yeah, inferring missing table data from other data.
Okay, fine.
Yeah.
Fine. It just so happens that the table, if it was filled in, would give you relative frequency. No, it doesn't even give you relative frequency. It's a marginal table. Isn't it a marginal frequency table? What is that, marginal?
Well, they gave was 2 marginals.
Yeah, 2 marginals, right?
They omitted a 3rd marginal.
Well, they gave you this marginal.
And then they omitted one of the column marginals, and they gave you another column marginal.
Marginal. The reason why they call marginal probabilities is because they're in the margin, which is sort of like the outside of the main part of the table.
Yeah. Well, they're not probabilities. Okay. They are counts.
They're counts, right? Yeah, but then you divide by the total number of presidents in the study, and then they become probabilities. Okay.
Yeah.
We've done.
Well, let's see. So given the data. Okay, Joel, you figured out that 11 should be here.
Oh, right. Yeah, 11 should be there.
So from the 11 and the 24, we could figure out that there should be a 13 here.
Right. Yeah, we got
and now.
Yeah.
So we can now calculate the column marginal.
Yeah.
5 and 4 is 9, and 1 is 10. We could fill in 20 here.
Right.
Okay. Now, since we're given the column marginal for 4 and 13, we could figure out that there's 6 here, and then 6 plus 4. We could figure out this. So 10. So the table, this actually, this problem may have originated from another problem, which was that so this is the total of everything.
Look, it even works. You add these.
Of course, of course, yeah, of course it works.
Yeah, of course it works. Yeah.
So the 20 plus 23 should be 43, and similarly for this column, it works because I calculated the numbers that that add up to the given marginals, and then I ended up with the steps where there's only one unknown.
Yeah.
In each row and each column. So this may have originated in the following problem. Here's a table with missing data. We know, given this one relationship, given this one relationship here, can you complete the table? In other words, does this additional relationship define the table uniquely?
Okay, you don't have to say it more than once. Okay.
Yeah.
Got it. Now, but I have a question. I have an interesting question. So, knowing me, I would do it by brute force. If you just change this to an 8 because the percent is different, and you just decide, I'm going to make this an 8.
Yeah, sure. Then you'd have to make the 13
right.
be a 6. Was it a 8? It would have to be a 16, and then you figure out everything else. So it still works.
Okay, still works. Okay, let's move on.
Yeah, the thing is, So given one.
Yeah, given one thing, you can fill out everything else.
Yeah.
It's sort of like Sudoku. You figure out one thing, everything else.
Yeah, it's a Sudoku. Yeah, exactly. It's a Sudoku type problem.
By the way, strongly encourage everybody to do Sudoku, particularly if you're going into geometry. Next question.
I say that if you want to prepare for college, this is the kind of thing. This is the kind of what we illustrated is the kind of analysis and criticism of things that you're given on paper that you will do in college.
Yeah. Yeah. I spent most of my time in engineering school, but we just did problem sets. We didn't really criticize anything. We just had to calculate all this stuff. Okay. Great. Okay, here we go. Second question, because that was too weird of a question. Do they say what the topic is? I hope so. Yeah, they do. Good. Okay, multiple choice question. Here we go. Please try it, pause it, and come back. Okay, star age versus distance from galaxy center. Age in billions of years. Ooh, pretty far away. Okay, a particular galaxy is being used in a study of star formation. The table partially represents the study's preliminary observations of star age versus distance from the galaxy center. Oh God, there's sense of this thing again. If about 13% of the stars included in the table were older than 10 billion years, okay, that's wait, we have to annotate. If older than 10 billion years, and also over this one. So why don't we just put an X here, just for now?
Yeah.
Just as a placeholder. From the galaxy, approximately how many stars are that? Oh, that's easy. That's what? That's 13% of a. Wait.
Yes.
That's 13% of 1118. Wait, maybe I'm going too fast.
Yeah.
Yeah, if 13% of the stars included in the table, fine. You see the word stars included in the table? we can replace
Yeah.
that with 1118. So we cross that out. Yeah, 1118. Yeah.
1,118.
I'm going to do something so that's not going to like. I'm going to cross this out. I'm going to replace that with 1118. If 13% of 1118 was X, then how many stars is that? Isn't that, yeah, it's just 13% of 1118, right?
Yeah.
This is the same stupid problem as the last one.
Yeah, same stupid problem. That's right.
What are we going to do?
And I think it's and furthermore, this data is not sufficient to fill in the rest of the table.
Okay, we spent enough time in these stupid problems, so let's just see. Okay, and then the answer. This is the same problem. Wait, let me clear. This is really really like crazy. Are they going to get to a legitimate problem on probability and relative frequency like they did on the non-digital side?
Yeah.
Oh, look at that! They're using bold. They want you to be careful there.
Yeah.
Yeah.
Yeah. So this problem pertains to figuring out which entry in the table corresponds to a description in English.
Right. So, whoops. Doesn't it border on the concept of conditional probability?
I rather than worry about relating it to a more complicated concept, we could describe what the problem is about in terms of a simple explanation.
Well, yeah, I mean, we did that when we did that already. We did that when we did the problem. When we approached the problem.
And then if you want to be, then you could say that that X is the X. No, the thing is, they make no reference to the total for the row.
Right.
Unused is
unused, yeah.
Unused, and they make no reference for the total of the column. All they make reference to is that X over the total number of stars observed, which they tell you, they actually figured it out for you, is 1,118 equals how much? 13%. So I would say it is not a conditional probability question. It is a simple probability question. You're given the probability. The 18% is, if this is mapped into frequency-based probabilities, 18%, or is it 13%? 13% is the probability that if you pick a random star from those observed, it would be older than 10 billion years, and it would be further than 1,500 light years away.
Yeah, I mean, it's semantic, whether you call it probability or conditional probability.
No, it isn't.
No, I think
we did not. We did not take any condition.
Yes, we did. We said if.
No, yeah, no. It's conditional probability only for a trivial condition.
So, but it has the word if in it. It has the word if in there. If.
Don't say no. I object to saying there's anything to do here with conditional probability.
Well, there's a condition.
Do you want? Maybe you should explain what conditional probability is, and you'll see why it's irrelevant to this problem.
You know, my let me admit, I don't know that much about probability.
If everybody's listening to this, do your homework. Learn what conditional probability means.
I thought this was bordering on conditional probability because it's saying.
But maybe everything borders on everything else. But the question is it or isn't it? In math, a lot of many of the fundamentals in math are about is or isn't, not about bordering.
Okay. Look, I don't
know. It's 1 plus 1. 1 plus 1.
Yeah.
Does it equal 3?
No.
Okay,
look. What is the
1 plus 1? Does it equal 2?
Seth, explain to me why this is not. Then explain to me what is conditional probability.
Conditional probability is the following. You have a set of things that might happen.
Yeah.
It's called the sample space.
Right.
Okay? And conditional probability is when you specify a subset of the sample space.
That's what we're doing.
No, we didn't.
Yes, it says if.
No. I didn't finish the sentence. Where you specify a subset.
Right.
And 2, look at the probability that some combination of events happens, given that what happens is in the subset that you're given. So if C is the condition set of things, and let's say X is the event that you're concerned with. What we talk about is the conditional probability that X happens given that C happens. Now we could fit this as a definition in terms of the probabilities in the diagram. This is the probability that both X happens and C happens,
right,
divided by the probability that C happens. So the definition of conditional probability, conditional probability is the ratio. The conditional probability pertains to two events. It's the ratio of the probability that they both happen to the probability that the second one happens.
Okay, so I have a question.
And so what you could say, if C equals the whole, if say U, if U is the whole sample space,
right?
U, the probability of X equals the conditional probability of X. The conditional probability of X given the whole sample space.
Right, so it's divided by...
And that is equal, that's of course, is the probability of U is 1. The probability that something happens is always 1. This is by definition of conditional probabilities, of the probability of X and U divided by the probability of U.
Right.
So divided by probability of U. Now let's write this out. Probability of X and U is equal to the probability of X. No,
That's you
that's
put a
easy.
union. You put a union there. You don't need a. You don't
Yeah,
put
I
a
don't
union.
care. Yeah, you're right. Yeah, yeah. As an intersection or
It's an
and.
intersection, right?
This is the probability of X. Why? Because U is everything,
Right.
and everything U intersected with anything is equal to the anything.
Right.
So this is
No, it's equal
probability
to
of
the.
P intersecting
Yeah.
U is equal to
Right.
probability of X intersect U is the probability of X,
Okay.
and the probability of U is 1.
Got it. Okay. Okay.
So
So.
if you call this conditional probability, the only thing it is a trivial case of
Wait.
conditional
Okay. So
probability.
then let me ask you a question. Let me ask you a question. Is there any way that we could take this silly table, okay? Take this silly table
Yeah.
and write it out, and then this thing applies. That you can somehow get this thing to apply in some non-trivial way. My gut feeling, which is
Well,
which
you
I
can ask a different
absolutely will not
question.
trust,
You can ask a
yeah,
different question. No,
is
the different
yes,
question is among the young stars. Among the young stars,
yeah,
the ones that are between 0 and 2 billion years old, among those only,
right,
what fraction are far, far, far away? We can ask, okay, yeah, we can
no,
ask a question whose answer equals 230 divided by 424.
that would be conditional probability.
Yeah, yeah, yeah. So that would be the problem that if you choose uh if you choose a randomly a star that's between 0 and 2 billion years old, what is the probability that it is more than what 15,000 light years away?
Wait, but you're really confusing me now. If you say that this is conditional probability,
Yeah.
and I said that x over 4x over 481, that's what we were dealing with. We were dealing with
Well, you
x
could
over
do that too.
481
Yeah, sure. Yeah, that
is
too. You could do the same
0.13.
thing.
That's conditional probability.
Well,
I mean, if you're calling this conditional probability, then what we just did
oh,
is conditional probability,
oh, okay.
right?
What they are. So I think I'm wrong. I'm wrong. I think
Yes, I knew it. I knew
the
it. I
input
knew it.
data.
I knew it.
Yeah. Oh, I see your point. I see your point now. I see your
Yeah,
point now.
yeah.
Okay. So what they told you was the conditional probability. A star is further away than 15,000 light years. The conditional probability is further away, given
Right.
that it's really old, is
Right.
okay.
Is 13%.
It is
0.13.
no. You're driving me crazy.
Okay.
No, in this problem,
Right.
in the problem on the board, the probability that you're given 13%
Right.
is the probability that a star is in this category among all the stars in the whole
So
table.
I was wrong. I was wrong.
Yeah.
Oh. Oh. Oh, I see what you mean. Conditional probability
So
would have been x over 481, but this is x over the total.
yes.
Oh.
That's why this. So the case is this is a case where
Oh.
it's conditional, but it's conditional on with under no condition. It's conditional under all over anything.
Oh. So the condition is.
You are confusing this with the previous question.
No, I'm not confused with the previous question.
In the previous question, they gave you an piece of input information was a conditional probability.
Okay. No. You know what I'm confusing with? Maybe this will explain why I'm confused. This is an important approach to think about why you're confused. I'm confused because I made a mistake about conditional probability. I thought probability is conditional when there are conditions and you set up the problem. There are conditions when you set up the problem. I thought that's what conditional probability is.
No.
Oh, conditional probability.
Well, every problem has conditions in the setup.
Oh, you mean like what's the probability?
Every problem, every problem except for a trivial problem like true.
Yeah, well, we're not talking trivial problems. So you're saying even
every problem consists of information, and you have to figure out mathematical other mathematical information from the given information.
Oh, okay. So in other words,
and the given information is conditions.
Okay, so in other words, you're saying that if I what is the probability of rolling a 1 on a 6-sided dice? Well, I could argue that that's a condition.
The condition is that you have a 6-sided die.
Right, and you're rolling. I'm rolling a 1. That's my.
Yeah.
But that is not. That obviously is not conditional probability. Just what is the probability of rolling a 1 on a 6-sided dice is not conditional probability. But in my stupid definition, it would be because it's a conditional, which is incredibly stupid. So I see. So that's how I was interpreting.
Well, say approaches to studying.
Yeah, approaches to studying.
Approaches to studying. When you've heard of words in your subject,
yeah,
ask somebody, look in textbooks,
yeah,
look on Wikipedia to find out what the word means.
But the thing is with this situation, every time I see one of these frequency tables, I always say to myself, conditional probability. So,
well, don't do that.
Yeah, but what difference would it really make? I would still probably get the right answer. What difference does it make? Yes, if you're going to go into probability professionally, and you're going to get a PhD in probability, and you're being tested on this, then it makes a difference. But if you're just doing this,
it makes a difference when you go to college, and you take courses in many subjects, right. even subjects like history, psychology, sociology, business, economics. You're going to have tables, and you're going to evaluate relationships about the data in the table.
But whether you call it conditional probability or not, as long as you know how to do it, that's the important thing.
Yes.
Yeah.
But the point of knowing the vocabulary is that someone may use the vocabulary, and if you don't know the vocabulary, you will not understand what they're talking about.
Right, that's right. Words have meanings. Yeah. Okay, so I guess.
Okay.
I guess this is a.
So we're going off on how to approach studying and doing well and getting something out of your education. How to approach getting educated.
Right. Yeah.
Right.
Yeah. Respect for the vocabulary.
We're going beyond the SAT.
We're going beyond the SAT. Study of respect the vocabulary, because the vocabulary really is important. Particularly when you need it to be important. If you're just casual, you could do poor vocabulary.
Well, generally, I think the greater accuracy vocabulary is used, the better it is.
Yes, the better. That's right. That's
And problem with today's world is that that there's too much looseness in the use of words.
Oh boy, I guess I should resign from our position here.
Yeah. No.
But I'm a good.
Well, we need to have a contrast.
Yeah, it's good to have a contrast, right? Yeah, yeah. See, as educators in I just want to get the right answer. Yeah, but getting the right answer, the way to get the right answer is you have to understand what you're doing. And sometimes you can be a little looser than others. Seth is PhD math. You gotta everything, every single letter and everything you say, every concept, everything you say has to be right. It has to be well defined, and everyone has to understand it because you're communicating with other people. So, anyway, I think we are seriously done today.
We're done. Seriously done.
So if you're dying, don't worry, we are not going to do this. If you're dying to know if the next question is the same weird thing, which is not probability or condition or whatever they said this was, if frequency, if you're dying, then go yourself to the third problem. See what it is, because we won't be getting to this topic for a long time because we're going to be cycling through all the topics. But we will eventually get back to this months from now. Maybe not months, but like, I don't know how long. Okay, everyone, have a great day. Like us, dislike us, give us comments on our YouTube videos. We'd love to hear what you think of what we do. If you've even gotten to this point, which is probably not very likely. Anyway, if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com, and we hope to see you tomorrow. Okay, have a good day. Bye-bye.
Yeah.